So first of all, we have to apply integration by parts to show that it has this in it. Alright, but the n minus 1 version of that. Alright, so let's do it. So you can see that we're going to need the 1 minus x squared to the n minus 1. So I'm going to save that for differentiation, and I'm going to differentiate integrate 1. So I'm going to differentiate this bit and integrate the 1. Alright, so let's do that. So I get an x, and I've got 1 minus x squared. 1 minus x squared to the n. I don't know why I've got that there. Too many brackets. Alright, and that's between 0 and 1. Minus, alright, so the one I have integrated is x. One I am differentiating is this to the n. So the n is going to come at the front, and it's going to be n minus 1. And I'm timesing by negative 2x as well if I go inside that bracket. Alright, you can see here if I put the 1 in, it goes to 0. If I put the 0 in, it goes to 0. So that whole square brackets disappears. So what have I got here? I've got, so I'm going to put that minus 2 out the front as well with the minus n. So I'm going to have a positive 2n. If I just collect things, I'm going to have an x squared, 1 minus x squared to the n minus 1 dx. So you can see there that I've got in and it equals 2n. Now that is exactly what jn minus 1 is equal to. Alright, so that's done. Remember that, we'll need that later. Okay, so for the next part, we have to hence show that. Alright, so if I just have a look at the, I just got jn minus 1 there. So let me look at jn minus 1. There's a bit of a, see if I can get everything in terms of in using this one. So I've got x squared, 1 minus x squared to the n minus 1 dx. Alright, if I break that x squared there up into, so I want it to be like the bracket, so I want it to be negative, so I'll put a negative at the front as well. And I want to add 1 and minus 1. There we go, so it's still positive x squared. And then I've got 1 minus x squared still, n minus 1. So again, I can do this times this. So bracket times that, and then I'll do that times that as well. So I'm going to get two integrals there. So you can see I'm going to have a minus integral that is just 1 minus x squared to the, so n minus 1 plus 1 is n. And I'm also going to get 1 minus a positive 1 minus x squared, and that's going to be n minus 1 for the second expansion part. Alright, and you can see straight away that that is minus in, and this is positive in minus 1. So knowing that jn minus 1 in terms of in is in on 2n, if I just rearrange that one, so in on 2n, and I've got that and that. If I put all my in's together, I'm going to have 1 plus 1 on 2n, lots of them over here, which we know is 2n plus 1 on 2n. Just move that up a bit. Alright, so then in will equal 2n on 2n plus 1, in minus 1. Alright, so let's just check, is that what we wanted? Yep, there we go. So now we've shown that in is 2n on 2n plus 1, in minus 1. Alright, so let's go to C. Now from what we've just done, so from B, what we've just done, we know that jn minus 1 is equal to minus in plus in minus 1. We had that, and then we kind of substituted the in on 2n in. So that was kind of like our second last part. So we already have that, so let's use that. So if I change that to jn, we're just adding 1 to each one. We're going to have, so this one will be in plus 1, and this one will be in. So if I just rearrange that, there we go. So we've shown that. That's just using our part B. So I could say from part B. From part B that. Therefore, let's have a look. So I'm going to have in, because it says hence deduce. In minus, so if I look at in plus 1 in terms of some j's, because I want all of this in terms of in, so I need to get rid of that in plus 1 and bring in some j's. So let's look at this. So you can see it's going to be 2n plus 1 on 2n plus 1 plus 1 in's there. So let's do that. So that'll be 2n plus 1s on 2n plus 1s plus 1. And then we've got in. Alright. So that's just using, that one's using, oops, sorry, my error, it should be, so that's using B again, but we just want to go back to terms. It's because it's asking us to put it in terms of in. Alright, so we've got in here, and then we've got minus 2n plus 2 on 2n plus 3 in's. So if we think about that, that's a whole, so it's a 2n plus 3 on 2n plus 3 minus a 2n plus 2 on 2n plus 3, lots of in's. So therefore jn equals, so 2n minus 2n disappears, 3 minus 2 is 1 on 2n plus 3 in's, which is what we wanted there, so that's C. Alright, so using C, let's have a look at D. It says hence, so we want a reductive formula for jn in terms of jn minus 1. So we really just need to, we've got it, we just need to change that in terms of j, and we have in part A, we have in is 2n jn minus 1. So we get 2n on 2n plus 3 lots of jn minus 1. So there's our reductive formula for our j's.